practicing so that you can actually do well in the exam. So we were talking last class. We gave versatile example of the linear and nonlinear operators. We talked about operators. We saw that how the operators appear in chemical engineering problems, how algebraic systems, AX equals to B, these kind of things, this type of things actually so powerful to solve regular plant engineering problem, regular process engineering problem, and also if you want to look at the differential system, complicate differential equations, how it will become even regular kitchen kind of problem. So, it is actually, in last 3 classes what I tried to establish that mathematics is everywhere in our daily life, and of course chemical engineering has enormous amount of mathematics, and if you understand mathematics properly, it will be easy for you to solve many complicated problems. A lot of time will be having intuition, but intuition can be mathematically established, and in that case you can get quantification, you can get magnitudes of different properties, and intuition will give you some kind of thing. Okay, this space is hot, this space is cold. What is the temperature? But this space is having no concentration, this space is having a maximum concentration. What are the values? So if you want to quantify, you need to have some numbers, and those numbers can be done by mathematics. And how to get those numbers? To solve the algebraic system and the differential equations. So that's the way the essentiality of the mathematics will come in picture. So I would like to summarize what we have done for the operators. So LU equals to F. We have differential and matrix operator, and this has 2-part homogeneous and inhomogeneous part. Any operator has it. For example, if you look at differential operator, it will be dx square plus say du dx plus u equals to 0, homogeneous equation. If I put 5x, non-homogeneous. And this is of course a linear operator, right? This is a classic example of linear non-homogeneous operator. The classic example of linear non-homogeneous differential equation. In that case, how to get solution for this system? You have done in your 10 plus 2. How to get the solution? What are the solution in 10 plus 2 calculus? Pardon? There is something, some solutions actually. If you put 0, what is the solution name called?
Complementary function.
Complementary function. And then other solution called as particular integral. You know very good mathematics. So CF plus PI. Okay? What actually happens? That CF and PI, they are the independent solution. Okay? And since so CF actually satisfy, complementary function satisfy the homogeneous part, and non-homogeneous part, particular integral, will satisfy the non-homogeneous part, and since both CF and PI are the solutions, and they can be combined to have this solution, because we know that any operator is linear operator. We have alpha u1 plus beta u2 equals to alpha lu1 beta lu2. We could do it because of linear operator. So now earlier what you are doing, you are just doing just like mugging. This is the rule. Even if you could not ask your class teacher because no explanation. Now you can explain to yourself. Okay, I have linear operator. For the linear operator, okay, I know the complementary function and particular integral. Why they are added? You never ask why not subtracted. You could have subtracted CF minus PI. You could have multiplied CF with star PI. Why plus? Because of this. Because operator is linear. If I put like this, then you cannot do this thing, I don't think. You cannot do it. Because operator is no more linear. It is not valid. These kind of things cannot be applicable for non-linear operator. Right? So many things I talk. Any questions? So if the operator is not linear, you cannot have alpha lu1 plus beta lu2. Okay? Where u1 and u2 are the two solutions. For example, here this is complementary function, particular integral alpha and beta. Then we have value of complementary function, the satisfying and the particular integral. So this is valid. This is based on. So when you have, so basically what we did, when you have a non-homogeneous, linear operator, we take always the inhomogeneous solution, add it up and get the final solution. Because the operator is the linear operator. Similarly, for Ax equals to B, we can ask a question. This is the non-homogeneous matrix operator. Why we are not doing the same thing here? Answer is, can we do the same thing? Homogeneous solution plus non-homogeneous solution. Answer is, you are always doing that because homogeneous solution case it is Ax equals to 0, homogeneous part. And homogeneous solution, if the determinant of A is non-zero, it can be shown that X is 0, trivial solution. X is 0, trivial solution. If you want to verify, you can do like this: x1 plus x2 equals to say 2, and 2x1 plus say, x1 plus x2 equals to 0, and 2x1 plus 2x2 equals to also 0. We have 1, 1, 2, 2, x1, x2, 0, 0. But actually you can see that determinant is 0. So that means essentially you have only one equation. These are just dependent equations. If you multiply this, you get. So that doesn't mean that if you have two algebraic equations, they're independent. They could be dependent. So in that case, if you put x2 equals to minus 5, x1 equals to plus 5, x2 equals to 0.1, x1 equals to minus 0.1. So you can get infinite solution. But if you have x1 plus x2 equals to 0, 2x1 plus 3x2 equals to 0, we have 1, 1, 2, 3, x1, x2, 0, 0, and this could be only possible if and only x1 equal to 0, x2 equal to 0. Because determinant of A is non-zero. So essentially for the independent equations, algebraic equations, the Ax equal to 0, the homogeneous equation. So what is the solution for this case? Solution is x homogeneous plus x non-homogeneous. Okay? Vector. Homogeneous solution is 0. X non-homogeneous satisfying x non-homogeneous equal to b. So what we are getting only this part, homogeneous already taken care of the 0 solution. So we are doing all the time homogeneous and non-homogeneous split. Any questions? Any doubts? Any confusions? Okay. So this is the concept. So you can see that this operator theory concept is everywhere. So you can, if you want to solve the algebraic system, if you want to solve the differential system, no matter you have homogeneous, no matter you have non-homogeneous, you can split up homogeneous, non-homogeneous, and get a unified approach to solve the system, provided operator is linear. Fonda is clear? Yes? Okay. So basically what we actually see that we have the matrix operator, differential operator. So this operator is pretty straightforward because when you want to solve Ax equals to b, we don't need any kind of boundary condition. Directly we can get solution. Okay? And so what are the matrix operators? Ax equals to b, okay? And this A is matrix, X is vector, B is also vector, right? Matrix, vector, and vector. So the solution actually in the vector space, and one need to know, one has to know the matrices and vectors. So I will be talking about next couple of lectures about the matrix and vector and seeing the properties. If you know the various properties of matrix and vector, you can. So many of the time we want to know the analytical solution. We want to have the different kind of solutions, and for and matrix and vectors properties play a critical role to obtain, to analyze the solution, to assess the solution in these matrix operators. So I think after this introduction of the general operator format, the seeing that differential operator, matrix operator, so one can talk about the matrices and the vectors. Okay, so we talk about the matrix operators. We have say U equals to B, A is the matrix, U is the vector, or V is the vector, U is the unknown vector, and V is the known vector. And if A is, say for example, A11, A12, A21, A22, and U vector is U1, U2, it is possible to prove A alpha U equals to alpha AQ. Can you prove it? Okay. This is one of the operator properties. This is basically, in fact, when I talked about the linear operator, this part is covered. In fact, this actually implies L of alpha U is nothing but alpha LU. Yet the operator is linear because the coefficients are constant. A11 constant, A12, A21, A22, all are constants. And the answer is, if you can do it, how can you do it? To prove it? How can you do it for this 2x2 system? Any ideas from your side? How can you do it? Any ideas? Alpha is a scalar quantity. Alpha could be numbers. 1, 2, 3, 4, 5, any numbers. How to prove it? No idea. Matrix operator, I have done it in the last classes. I have done difficult problems. It is much easier. No ideas? What is alpha U1? Alpha U bar? I am shocked that you are not able to see that this is actually a school level problem. Yes. How can you do it? I am only hearing some whisper sound, nothing else. Multiplication, exactly. So easy. A21, A22, alpha U1, alpha U2. Okay. So what you do? Multiply like this. So you get A11 alpha U1 plus A12 alpha U2, A21 alpha U1, A22 alpha U2. The same results you will get from alpha AU, right? If you multiply A and U and multiply by alpha, you will get the same result. So that's it. It's so easy. I thought you'll be doing it 1 minute, but I got only 1 or 2 answers. Okay. So matrix operator, we have found that it is actually very straightforward, and it is so similar manner you can actually prove this one. You take 2 vectors. U vector is U1 vector. So what you can do, you can put a vector here. So U1 vector is U11, U12. Similarly, V vector is say V11, V21, V22, and you can subsequently so you can have U1 vector as U11, U21, V1 vector is V11, V21. Do the same operation, try to prove it. You can prove it, right? I don't think you want me to do it in the class. You can go back home and try to prove it for 2 different vectors. How to prove that the matrix operator is linear? Only take 2 by 2 matrix. If it is valid for 2 by 2, n by n matrix also it will be valid. So no need to worry about it. Okay, let's see more on the matrices. How are the properties? Quite often matrix is called as m by n matrix. That means m rows and n columns, right? It is not aiming to n by n matrix. M by n matrix. So m rows, n columns. So A11, A12 up to what? A1, n or m? N. A1n. Okay? N columns. N columns. A21, A22, A2n. AM1, AM2, AMN. This is the way we write the matrices. This is the way we have learned in the class, in school. And when we talk about AX equals to B, these both are called as column vectors. These both are called as column vectors. And how they look like? X1, X2 up to Xn. And sometimes we write X transpose as X1 to Xn. Transpose means row goes to column, column goes to row. Okay? So X transpose is row vector. Okay, and same thing will be valid. So U and V vector are the column vectors. Okay, so what will happen? U bar V bar transpose. What will happen? So before doing the mathematics, we are all engineers. Try to do intuition. U vector. So what is the order of the how to write? It is in terms of m by n. It is how to write? No 1 by n. It is how many rows are there? N rows, 1 column. N by 1. N by 1. So it is n by 1. And it has to be compatible to multiply. Only the number of rows should be number of columns. Otherwise we cannot. Right? So it is 1 by n has to be. It cannot be n by 1. If it is, you cannot multiply. Because matrix multiplication rule says that the first matrices, any vector also can be treated as matrix because only one column. So first matrix number of column should be or must be equal to the number of rows of the second matrix. Okay? And so what will be the, if I write U J Vj and J equals to 1. It's a matrix. N by n matrix. Okay? So these are the properties one can actually think about any matrix. So these many more properties you can go to the Grewal's book, you can go to Test book, you can get a whole lot of matrix properties. I am not going to that. These are all covered in undergraduate level. Matrix A, we write always Aij. With the square matrix, we write n by n. B matrix, we write Bij, write n by n, square matrix. Okay? So Ij denotes the element. I and J denotes the generalized one element. Location is ith row, jth column. Location is ith row, jth column. Location is ith row, jth column. So A matrix, B matrix, Aij and Bij, they denote the element in the generalized ith row and jth column. And n by n, they talk about the square matrix. And it's a 2 matrix, they are equal. It's a 2 matrix, they are equal. That means Aij equals to Bij for all I comma j. This is the symbol called for all in mathematics. For all I and j. So Aij and Bij, that means each and every element. That means each and every element of a matrix must be same. That is Aij equals to Bij for all ij. Okay? And could be, if you want to talk about the generalized case, then again non-square matrix is possible if it is m by n or n by n, whatever, for all I and j, any of all of the rows, it has to be valid. So, what are the operations in matrices? So we are now going into much detail of the matrices and different kind of different types of operations. Okay, so matrix sum. So matrix sum, what we write? A plus B. It is nothing but the element should be Aij, Bij, Ny. I am talking about the square matrix. Could be non-square matrix also. So A plus B, if you add, you get C matrix. Where you have, this is equals to say called C matrix. We can write Cij equals to Aij plus Bij. Okay. Next is matrix multiplication. Okay. The multiplication of A could be done by any scalar lambda, and K is what? Numeric field. Numeric field will come later when I talk about the details of vector space, but for your benefit I am saying that a numeric field is a set of numbers, any number, a set of numbers, any real numbers we have, and one number I can pick up, which is lambda. K is the entire set or numeric field, and lambda belongs to K. If you look at the set theory, I think set theory has been covered in 10th level, right? We have done relations, functions, everything, right? In 10th level. If you look at there, you have seen this kind of symbol called belongs to. Belongs to. So, if you look at your 10th level mathematics, it is actually discussed relations, functions, everything. So, a scalar number could be pick up, could be 4, could be 4.5, could be 7, belongs to numeric field, such that lambda A, whose element could be lambda Aij. Element could be lambda Aij. Many of the mathematics book will write this fashion. Doesn't matter. Matrix product. Next property is matrix product. I just talk about the two generalized matrices. A matrix, Aij, M cross P, B matrix, which is having P cross N. Has to be. Otherwise, the first category, first matrix is number of rows, number of columns should be equal to number of rows of the second matrix. So A and B can be multiplied. If they are basically non-square matrix, you have to be very careful. If they are non-square matrix, you have to be very careful, because the first matrix number of rows should be equal to second matrix number of columns. In that case, the vector is a classic example of non-square matrix. If you say that you don't talk about the non-square matrix, yes, we talk about, because Ax equals to B, X vector and B vector are the classic example of non-square matrix. We are dealing with a predicate, which is vector. Any vector is a non-square matrix, right? Because number of rows, not even number of columns. Okay? So in that case, when you multiply the two vectors, that means you multiply the two non-square matrix, and you have to be very careful the number of rows and number of columns matching. If they don't, you cannot. So this, so you can get C matrix with that, and the Cij will be equals to K equals to 1 to B, Aik and Bkj. I will just, this is the mathematical symbol, but I will tell you that matrix multiplication is not that complicated. If you have A11, A12, A1n, A21, A22, A2n, and An1, An2, Ann, we have B11, B12, B1n, B21, B22, B2n, and Bn1, Bn2, Bnn. I am just considering two square matrices. We are getting C matrix. Sometimes while doing multiplication you get confused, you do mistakes. Okay, how to avoid the mistake? For example, this is the first row, second row, third row. Third row, this could be third row, fourth column. Third row, fourth column of C matrix. Okay, so without thinking much, we can say that, okay, I have to multiply of third row of A matrix with the fourth column of the B matrix. Right? If you think that way, any of the elements you can actually derive. Okay? So third row will be having what kind of elements? A3, 1, 2, A3n, and it is multiplied with the fourth column. That means last number will be 4 only here. That means B1 4, B2 4, and Bn 4. And now you are seeing that this one all are common. Okay, and that's why this is Aik, Bkj, K equals to 1. Okay, so any of the entries. Okay, fifth row, third column. Fifth row of the first matrix A, third column of the B matrix, you multiply, get the entry. You will never forget matrix multiplication if you remember this. You will never ever forget. Okay, clear for the matrix multiplication. So that's the way matrix multiplication actually goes. let's talk about, so for this case I equals to, let me finish the definition here, and it is for I equals to 1 to n and j equals to 1 to n. That is the way the I and j can be defined. Next we'll be talking about some more properties. First is AB equals to C matrix. Second is there will be something called as commutative property and distributive property, also associative property. This type of things you have seen. Okay. So matrix product is associative and distributive. Distributive with respect to the sum of some, but not in general commutative. So matrix product is distributive and associative. This is the distributive property, associative property. It will happen for matrix product. But if one would like to write AB, it cannot be B. So matrix leads to commutative property. Matrix generally, two matrix generally will not commute in general. The matrix in general, if they commute, something will happen. I will discuss that. Matrix generally don't commute in the for the product. But the at summation is okay. Summation, if you want to write, no problem. But this never happens. So when you talk about the commuting the matrices, look at the sum of product. Sum, okay. Product, no. You have to be very careful. So matrix distributive properties occur or associative properties occur. Next thing I would like to talk about identity matrix. Next I will talk about identity matrix. This part is clear, right? I think you all know all those. I am just going a bit quickly so that you can brush it up with your undergraduate text. Identity matrix. Okay, how it looks like 1 0 0 0 1 0, and last row has 1 in the last column. Okay, so this matrix I generally written as delta ij n by n, and beauty of this definition is delta ij equals to 1 if I equals to j. Delta is equals to 1 if I equals to z. Agreed? So that's why this matrix is called as diagonal matrix. That's why this matrix is called as diagonal matrix, because any matrix is diagonal if the matrix is non-zero, if it is I equal to j. If I is not equal to j, matrix is 0. In that case, matrix is called as diagonal matrix. Diagonal matrix also has the property where the non-zero elements will occur only at the diagonal entries. Non-diagonal entries like this, the entries are 0. So if you look at, this is the diagonal entry, here everything is non-zero. Here this part is 0, this part is 0. So this special diagonal matrix where the diagonal entries are 1. So this kind of matrix is called as identity matrix. For the identity matrix, what actually happens? They commute. That means if you write AI equals to IA. Okay? If we write AI equals to IA. Now the question is, any diagonal matrix will come. If I put any diagonal matrix, will they come? I have a matrix A. I have another matrix called I prime, which is not identity matrix, some diagonal matrix. Now my question is, do A and I prime will commute for the product? How can you prove it? Think about the proof. Think about the proof. Will they commute? If you say they don't commute, they can commute if and only all diagonal entries are same. They can commute. If they don't commute, you have to prove it. Why this will not be valid for the diagonal entries. Next is singularity of the matrix. Or sometimes I will just talk about AB another quick thing for the commute part. If it happens, what you can conclude about B matrix? B equals to? Or also something else?
Inverse.
Inverse, yes, it is inverse. Okay, so the matrix commutes, lot of interesting things coming out. You can see the concept of inverse. And if B equals to A inverse, A and B multiplication should be I. Okay, if B equals to I, the matrix will remain the same. Matrix will not change. If B is A inverse, entire operation will give I. So interesting. Beautiful. Okay. So when the commutation occurs, so AB equals to BA, two things can happen. B could be I. If it is I, then the entire matrix will remain unchanged. Nothing happens. If B is A inverse, matrix will become identical. Identical matrix. I matrix. So that's what I was saying, that when something commutes, so that's actually interesting. Next is singular matrix, which is more important. Singularity of the matrix or singular matrix. What is singular matrix? Matrix what? Determinant equal to 0. What does it mean physically? In chemical engineering, I am getting singular matrix. As a chemical engineer, can you reply me? What happened? Yes. Yes, you are very correct. That means if I am getting singular matrix in chemical engineering system, that means my client is not giving the sufficient number of equations. My client is giving less number of equations. In that case, I will not get unique solution for chemical industry, right? So singular matrix will tell us, okay, talk to the client, get the proper number of sufficient conditions to get the unique solution. So that's the usefulness of the singular matrix. So that is what, now talking about singular matrix, we have learned in 7th standard mathematics. How we learned in 7th standard mathematics? x1 plus x2 equals to 2. 2x1 plus 2x2 equals to 4. Imagine that this type of equations, if your 7th standard, your school teacher would have given to you, would have been really shocked. Such a simple system and getting answer is so difficult. What is that? 1, 1, 2, 2, x1, x2 equals to 2, 4. If you look at determinant equal to 0, right, of this system, that means what? That means what? That means it says that you won't get unique solution. Your matrix is singular. That means there are two unknowns and only one algebraic equation. You can get infinite set of solution for this case. So here in this case you may not need to do this analysis, because by looking at, you can say that you won't get unique solution because this equation is dependent, it's not independent. Okay? But if we have thousands algebraic equations, we have distillation column, we have deboiler, we have so many things, 1,000 equations we have got. In that case, it is very difficult for you to analyze this way. We have to look at the matrix, put in the GPROM software or the MATLAB software, check the determinant, check the singularity. You can say, okay, my client has given the sufficient conditions, so I can start analyzing the system. The singular matrix plays critical role for chemical engineering. Okay. And also for singular matrix, it is invertible, not invertible. The singular matrix is a matrix cannot be inverted, okay? Because determinant of A equal to 0. You cannot invert a matrix. That means you cannot get any A inverse when you have singular matrix. Next is transpose. Next we get transpose. matrix A, we have Aij n by n. A transpose, it will be Aji n by n. If it is m by n, it will transfer to n by m. This is the transpose of a matrix. Transpose of a matrix. And transpose has a lot of interesting properties. Let's look at, so we have seen the multiplication as some kind of property, and now we look at transpose properties. Property number 1, A plus B transpose, which is A transpose plus B transpose. Number 2, A transpose of so transpose of A transpose is the same matrix, A transpose. Transpose of A, and you could take the transpose again, you get the same matrix, right? Number 3, AB transpose equals to B transpose A transpose. How to prove it? How to prove it? Think about it and try to prove it. AB transpose equals to B transpose A transpose. You remember the definition of AB, right? Which is summation K equals to 1 to or P, P 1 to P Aik Bkj, right? Okay, and when you take transpose, what actually happens? If you take transpose, what will actually happen? Okay, think about it and get the answer. Number 4, ABC transpose will be equals to C transpose. Okay, first term is over. Next term, B transpose A transpose. It can also be proved. Okay, so this type of properties you can prove based on the properties, based on the property of product and transpose. Next is real symmetric matrix. When you talk matrix is symmetric, that means if you take the transpose, matrix will remain unchanged. Okay, matrix will remain unchanged. That means A equals to A transpose. Matrix will remain unchanged. That is valid for the if the all entries are real. That means if you have 1, 2, 2, 3, all real. If I put complex entries, the real symmetric matrix will not make any sense. Then what the matrix name would be? When the matrix is entries are complex, Hermitian matrix. Okay. So let's talk about the complex matrix. We have A matrix, which is I 1 plus I 0 2, and A bar is minus I 1 minus I 0 and 2. So you take the bar, which is conjugate. So wherever the entries are there, the complex quantity, it will be taken as conjugate. So A plus IB, complex conjugate is A minus IB. So it is I is minus I, 1 plus I, 1 minus I, others will not change. So this is the way the complex matrix will be dealt with. Okay. So when a complex matrix is there, you have to take A bar, conjugate matrix, complex conjugate of A. And in that case, this type of things will be replaced by A equals to A bar transpose, and sometimes we call as Hermitian. Okay. So if A equals to A bar transpose, then in that case the matrix is termed as Hermitian matrix. So here the difference is, for the real matrix A equals to A transpose, complex matrix you have a property called complex conjugate. Why to take complex conjugate? You didn't ask me this question. Why to take complex conjugate? I was thinking that you'll be asking me this question. Why to take complex conjugate? You could have taken A equals to A transpose here also. Why is nothing wrong? Why you are taking A equals to A bar transpose and then saying that okay, if it is equal, then it is called as complex conjugate. Why? Summation operator. Why? Why you take complex conjugate? There could be some justification. There could be some justification. Any idea why complex and complex conjugate will work together? Because if we look at when a complex appears, the conjugate has to appear, because when complex and complex conjugate they work together, they will produce length. U plus IB into U minus IB, you get what? U square plus B square, right? That's the length. Okay, that's called length. Okay. This length. For example, we write 1 plus 2y. Okay. In the organ diagram, we write 1 plus 2y. This is the coordinate. 1 and 2. The scale is not that good. So to get this, you have to get multiplied by 1 minus 2y, the square root. So complex conjugate has to appear to have something physically realistic, and that makes sense. And that's why we need to have complex conjugate when the complex quantity appears. Right? So complex conjugate will give the realistic value. So we're talking in terms of all the time realistic values. So that's why the complex conjugate is more meaningful to take into account. Next is something called orthogonal matrix. Next is something called orthogonal matrix. What is orthogonal matrix? A transpose A equals to A transpose equals to I, and it is proved that A inverse equals to A transpose. You can prove from here. In that case, the matrix is termed as orthogonal matrix. In that case, matrix is termed as orthogonal matrix. Okay. Next, let me have a quick problem. Please write the problem. If A is a symmetric matrix, and B is a general matrix, if A is a symmetric matrix and B is a general matrix, show that B transpose AB is symmetric. Show that B transpose AB is symmetric. There are two matrices, A matrix symmetric, B matrix general. So you have to show B transpose AB is symmetric. How to attack this problem? If a matrix is symmetric, both are real matrix. I am not asking, you can actually prove it for the Hermitian, for this complex matrix also by taking into account of this concept, but I am saying the matrix is real symmetric matrix, real matrix, so it will be A equals to A transpose if A is symmetric, but B is general matrix. So symmetric matrix, you have to use the property and attack. How to use the property? Take the transpose, yes, very good, take the transpose, equals to. What is that? So in that case, you can take this as a C matrix, and okay, so what will actually happen? A, B, transpose, and which will be B transpose, transpose. We will have B transpose, A transpose, same matrix. A is, yeah, A transpose is equals to A because A is symmetric, given. A transpose, this A and A equals to A transpose. So therefore, the B transpose AB is a symmetric, even if B is a general matrix. Next time we are talking about the very vital property which is called as determinant. And this here I will spend a lot of time and we will see that how easy to calculate determinant. Many of us actually get psyched to calculate determinant even the matrix size is more than 3 by 3, right? If it is 4 by 4, you will do a lot of mistakes, but we will be doing something interesting here to calculate determinant. So next property we're talking about determinant of matrix. How to calculate determinant of a matrix? The matrix is given, which is A11, A12, A1n, A21, A2n, A n1, A n. How did you do that in your school level? Not that way, but there are some kind of ways actually have done it. Cofactors minus, do you remember? Okay, what is that? You have to calculate cofactor and then calculate adjoint. What is that? What is that formula? What is the formula? Many of you, I can see that you are just giving blank face. Please read at home, otherwise you'll be having difficulty in this class. Please read at home. You are just giving blank because what I am asking, it has been covered in your BTech first level mathematics, right? It has been covered BTech first, so you have to give the answer from the BTech first level mathematics. What is determinant? How to calculate? What is that? Determinant of A, which is sum j equals to 1 to n, Aij, capital Aij. What is capital Aij? Cofactor or adjoint? Adjoint, yes. What's the difference between cofactor and minor? What is the cofactor and adjoint? I should say cofactor and adjoint. Cofactor and adjoint meaning is adjoint will be having the transpose, right? Yeah, row will go to column and also sign change. So adjoint will have sign change. Cofactor is more fundamental. Adjoint will be converted so that you can actually get determinant. This is a crude definition and I don't like it. I am not saying wrong. I don't remember. That's why I am reading from the notes. I don't like it. Even you also don't like it. If you don't like it, okay, you don't have to remember it. We will learn something new in this class. How to define the determinant. In that case, you don't have to mark any formula. You don't have to remember cofactors. You don't have to remember the adjoint. Without that, it is possible to calculate determinant for n by n matrix. That means if I give you 10 by 10 matrix, you can really do by hand and do the calculation. Believe me or not. Here in this process, if you do by hand, you will go crazy and you will drop the mathematics course. Sir is torturing us. But the technique what I will be teaching in the class, maybe next class, then you will just really appreciate this. Without this knowledge, we can get into the. Thanks for kind attention.